So just with this notion, Mackenzie, of distance and velocity and time, displacement, velocity and time, distance, speed and time, you saw from our little distracted driving activity, you could get some interesting data just from that. Many of you were shocked at how far you went through a school zone with your head down while trying to text in our simulation. But that's boring. Let's step on the gas. Let's hit the brakes. Acceleration is the rate of velocity change per second. We're going to underline that, even though it's a fancy schmancy definition. I'm going to give you a better definition, but we start out with that's how it's defined. The rate of velocity change per second. In this section, in fact, really all of this year, we're going to look at constant acceleration. We're going to let you hit the brakes. We're going to let you hit the gas. But we're not going to, once you hit the brakes, let you press the brakes harder or softer once you hit the brakes. Or we're not going to let you, once you've hit the gas, floor it even more or ease up. We're going to have a constant acceleration because that makes the math nice. If you want a changing acceleration, you really need calculus to do that properly. We will look at one situation next year where the acceleration is changing, but the part of it that's changing is its direction, not its magnitude. And so we can deal with that next year in Physics 12, but really need calculus. The units for acceleration, it is worth memorizing what units go with what concept. So the units for acceleration are meters per second squared. It's really meters per second, but we don't write it that way. So whenever you see a meters per second squared next to a number, that's an acceleration. That's a changing velocity. You're either speeding up or slowing down, or you're going around a corner, changing your direction. So far, so good, Louisa? Acceleration is a vector, but it's really tricky to visualize or interpret its direction. And the difficulty is it's easy to confuse acceleration with velocity. It's easy to confuse how your speed is changing with what direction you're going right now. The direction an object is moving and the rate at which it is moving are both related to velocity, not the acceleration. To determine the direction of the acceleration, we need to watch the object for a period of time and see how it's changing. In fact, we're going to do a little chart here. This is going to be the long, convoluted way. This is more intuitive. But then we're going to say, Ethan, there's got to be some way we can get there in one step without doing all these intermediate steps, okay? So we're going to fill in the chart. We're going to pretend that you have an acceleration of 1.25 meters per second, meters per second squared east. We'll call east positive, and we'll call west negative. Okay. And I'm going to start out, and we're not going to overcomplicate this, just relax. Colby, I'm going to pick on you, okay? So our initial velocity in situation A, VI, is going to be 0. So let's put 0 meters per second right there for situation A. What's our initial velocity for situation B? So I'm going to put plus 2 meters per second because it's easier to write a positive than write the word east. And I'm going to put the positives in because, the warning, we're going to be changing some directions later on here, so let's start with pluses and minuses right now. What was our initial velocity in situation C, my friend? What would be a shorter way to write that? Okay. With me so far? Nothing dramatic. You all see already got that right from that little stuff up there. You okay, Morgan? Morgan, what's the acceleration? It says the acceleration is as a number, what? It's up there somewhere also in that data.
1.25.
Good. 1.25 meters per second squared or meters per second. Direction? Now here's what that means. In all of these situations, we're going to accelerate. Which way? So if I start off at 0, after 1 second, I'm going to be traveling 1.25 meters per second because I'm accelerating at 1.25 meters per second, or I'm accelerating at 1.25 meters per second every second. can I stop saying per second or every second? Can I just say meters per second squared? But the reason it's squared is because it's meters per second every second. There's 2 seconds down there, but it's a lot easier just to say squared. You okay with that, Maddie? So I'm going to say that from now on. What if I started going at +2 and I accelerated east positive at 1.25 meters per second, 1.25 meters per second squared? After 1 second, how fast will I be traveling if I start out going 2? I think you're right. Yep. I'm going to go positive. All right. The trickiest one. What if I was going backwards, negative? So I'm in reverse, and I start accelerating forwards. I'm in reverse, but I hit the brakes, because if I'm slowing down in reverse, that's the same as accelerating forwards. After 1 second, how fast will I be going here? I'll give you a hint. Still negative. Yeah. Still going backwards, but not as fast. You okay with that? This is a sucky way to do it. We're going to find a shorter way to get to our answers, but we'll start out doing it this way. Let's go back to that top chart. After 2 seconds in situation A, how fast will I be going? If every second I'm accelerating to the east at 1.25 meters per second squared, how fast will I be going after 2 seconds? Instead of dropping down, let's do the next second. After 3 seconds, how fast will I be going? Colby. After 4 seconds, now here's the question. What if I want to know how fast you're going after 35 seconds? Do I have to calculate the previous 34? Or, please God, is there a way that I can get there in one step? And there is. That's what we're working our way towards. What about situation B after 2 seconds? How fast will I be traveling after 2 seconds in situation B? Hannah, how fast will I be traveling in situation B here? So we're still increasing by 1.25 meters. 4.5. I should have put a positive there and there just to be consistent with my notation, I guess. And after 3 seconds, Hannah? Okay. By the way, what does this positive and this negative mean? This positive, I'm just going to think going forwards. I'm imagining a car pointing to the right, because for me that's east on a piece of paper, and it's going forwards. So this negative, what do I think instead of forwards? But, yeah, backwards. It's in reverse. Okay? But, do you notice how the numbers, Morgan, got smaller from time 0 to time 1? It's in reverse, but slowing down in reverse. That's the same as accelerating forwards. The same way as going forwards, but slowing down, that's the same as accelerating backwards. That's a negative acceleration. So here's the real question. This is the trickier one. After 2 seconds, how fast will I be going in situation C? I'll give you one hint. Yeah, Ibrahim. 0.5. Is he right? 0.5? In fact, Ibrahim, somewhere right in here, there came a moment when we changed direction. In fact, we were going backwards. We must have come to a stop for a split second and started going forwards. Has to have happened. I don't think right at 1.5 seconds, and later on we'll actually be able to calculate when that occurred. But for now, I can tell you between second 1 and second 2, there was clearly a change in direction. It was slowing down backwards, came to a stop backwards, and suddenly you threw the car into forwards, started going forwards. What about after 3 seconds, Ibrahim? That's what you were going to say, right? 1.75? Is that right? But again, Mr. Dewick, what if I want to find out how fast I'm going after 40 seconds? Brady, do I have to calculate the previous 39? No. We're going to try and generalize this. So I wrote down here, there has to be a better way to do this. Please let there be an equation. Newsflash. Spoiler alert. There is. So, we start out with our definition of acceleration. Whenever the velocity of an object changes, the object experiences acceleration. Acceleration is defined as a change in velocity happening over a given time period. We have a fancy schmancy symbol for change in. What was the fancy schmancy symbol for change in? Triangle, delta. So really it's delta V over delta T. I put the vector sign on the velocity because velocity is a vector, time is a scalar, so I didn't bother putting one on there. Symbol for acceleration, whenever you see a lowercase a. Why not an uppercase? Uppercase A, something else. Amplitude, for those of you who are wondering, or if we're talking current, it's the unit amps. Okay. Units. Well, it's really meters per second. There's velocity. Per second, there's time. It's velocity over time. Except instead of writing meters per second, meters per second squared. Whenever you see meters per second squared, hey, that's acceleration. Scalar or vector? Does it make a difference which way you accelerate? It did in the last question that we did. Yeah, oh heck yeah. It is absolutely a vector. Velocity, v, has the same symbol as speed. Speed is lowercase v. Velocity is lowercase v with the vector symbol, that little half arrow over it. If the velocity, if we call our starting velocity vi, don't circle things, I'm just going to circle things for you, don't bother doing that. And our ending velocity vf, what does I stand for, do you remember? Initial, and f stands for? We're going to use that pretty much for the rest of the year for all sorts of situations. Then the change in velocity will be final minus initial, which means instead of writing triangle V, I can write it as VF minus VI. And we can make the same argument for time. Or A equals VF minus VI. Because time is always a change in, over the years, we get lazy and we don't write T final minus T initial. You're going to see it sort of like this on your formula sheet. I don't see this one on my formula sheet. You do, just in disguise. Oh, where delta is the shorthand for change in. Mackenzie, put a star next to this little note. Put a star next to this little note. This is going to become really important during the year. Change in anything. Change in anything is always final minus initial. That's going to be worth memorizing. Now, you will as the year progresses, but if in a month or so you don't know that, you want to repeat it to yourself, Morgan, like 100 times. Because if change in anything is final minus initial, when later on this year I ask you to find the change in momentum, you'll find the final momentum, you'll find the initial momentum, and you'll subtract. When next year I ask you to find the change in voltage, you'll find the final voltage, you'll find the initial voltage, and you'll subtract. When I ask you to find the change in anything, it's always going to be final minus initial. Since velocity has two aspects to it, speed and direction, magnitude and direction, acceleration can occur if speed changes, or direction changes, or both. But in this next unit, we're almost always going to be looking at situation A. A runner is racing in a 100-meter dash, and he accelerates from rest to a speed of 9.0 meters per second in 4.5 seconds. What's his average acceleration during this time interval? I alluded earlier to this DFIC approach that I'm going to try and hammer home with you. but I'm going to model that right now. Ethan, what's this question want me to find? Okay, acceleration. The reason, by the way, the reason I put average is I've watched runners in real life. They're not accelerating at a constant rate. Their acceleration does change. So if you ever see me put the word average, I'm hedging my bets and saying technically we're not finding the actual acceleration because the runner doesn't accelerate constantly. We're just finding an average. Okay, so what's it asking me to find? Remove the word average. What's it asking me to find? All of us, let's write down A equals question mark. Now, acceleration is a vector. I think if we want the direction reading the question, we'll say forwards, because I don't see any north, south, east, or west or anything here. So I'm not going to freak out about that. And then I taught you last day, I said you're going to look for numbers and physics words. And today I'm going to introduce you to your first physics phrase that you always want to notice. First of all, that 100. Gagan, what are the units right next to that 100?
Meters.
So what is that 100 if it's meters? Is it velocity? No. What is it? Direction? No. Distance. Maybe a displacement, but okay, D equals 100. I'd like you all to underline the following two words: from rest. That's a physics phrase that you want to, Lorenzo, notice every time. Ding, 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 ding. That should be alarm bell, pay attention, physics phrasing to you. What does from rest mean? Give you a hint. It tells me VI. What's VI if we're starting from rest? As a number, what's VI? It's initial, but what is it as a number? Yeah, 0. Okay, I will never tell you that again, but I will use the phrase from rest very often. Or you'll see the phrase came to a stop. That's a final velocity. What would your final velocity be if you saw that phrase? 0. Okay? I'll put the units in. Eventually we'll stop putting the units in, but along the way we'll check to make sure our units match. I keep reading. What's that 9? What are the units right next to that 9? Meters per second. So it's a velocity. Final or initial? Final, because it happened later. Also because I already know initial. Like, so there's a couple of ways I could reason that out. But yeah, from rest to a speed of suggests that's what we did later on. So V final equals 9. Then I see a 4.5. What's that 4.5? What are the units next to that 4.5? S. Seconds. What is that 4.5? Anybody? Maddie? Time. Now, eventually, in fact, I think in our next lesson, I will be giving you all of our kinematics equations. There's 4 of them. And eventually you're going to hear me say, I'm looking for an equation, has to have an A in it, and has some of this other stuff. But for now, I think it's this one here. Do a quick double check. Do you know V final? This is why we listed our data. Geo, do we know V final? Do we know V initial? Do we know time? We can find acceleration. What aren't we going to bother using? Don't need to use distance, apparently. They threw that in just for giggles. So I will write down A equals VF minus VI over T. Dom, what was V final as a number? Minus V initial all over T. You know what? I can do this in my head. It's going to be 9 divided by 4.5. It's 2 exactly, yes? I made this one work out evenly. 2. Now, for what it's worth, how many sig figs in the 9.0? How many sig figs in the 9.0? 2. How many sig figs in the 4.5? We divided. How many sig figs should I go to in my answer? So I'm going to go, instead of 2, 2.0. Units, seconds. No, not seconds. This is acceleration. Units, what? Meters per second squared. It's not time, Mr. Duick. Meters per second squared. Meters per second per second. Is that a big acceleration? Nope. What's a big acceleration? We'll talk a couple lessons from now about G's. 1 G's worth of acceleration. Next page. So, the standard, the SI unit for acceleration is meters per second squared. An object is accelerating at a rate of 1 meter per second squared if its speed is increasing by 1 meter per second every second. That's what meters per second squared means. There is another unit of acceleration that's used occasionally. I hate it, but we're going to use it here. It says this. Read along with me. A UFO is reported as accelerating from rest. Everybody right now, let's underline the phrase from rest. That's a physics term. What does that tell me? VI is 0. Okay. To 680 kilometers per hour in a time of 2.0 seconds. What's its acceleration? Why is this question yuckier than the one we just did? Can you spot it? Units don't match. Okay? Now, we are going to find this in kilometers per hour per second, which I hate as a unit, because bleh. But anyways, Morgan, what's this question asking me to find? What is its? My habit is I write down A equals question mark, and then I go through looking for physics words and numbers. From rest told us what? What was 0? Yeah, I got to be fussy. Somebody at the door there. Let me pause the video lesson for a second. Morgan, let's keep going. What's that 680? What are the units right next to it? That's a speed or a velocity. Is it initial? So it must be. Got to be. What's that 2? And I'll put seconds. I'm looking for an equation that has A, VI, VF, and T. And right now you only know one equation. Eventually this method will get more useful when you have a dozen or so that you're looking at. But for now, I think it's going to be A equals VF minus VI over T. I'm dropping the vector symbols because this question hasn't given us a north or a south or anything, so I'm being a bit sloppy here, Mackenzie. Really, I should say, what is the magnitude of its acceleration? That's all we're finding, because I don't know enough to say the direction. We're going to get this, 680 minus 0 divided by 2, which I can do in my head as well. Really, Morgan, at 680 divided by 2, I get 340 kilometers per hour per second. That would be these units. This mystery UFO is increasing its speed by 340 kilometers per hour every second. Now, I hate that unit. Yeah.
Why don't we just change the 680 kilometers an hour to meters per second?
Because there's questions in the homework that don't do it that way. Because the curriculum wants me to introduce this more obscure acceleration unit to you. Honestly, yep. I wrote here, Mr. Dewitt doesn't like the unit kilometers per hour per second, but I tolerate it, Evan, because of if you're driving, what speed do you get from your car? Kilometers per hour? And if you're actually timing something, if you're sitting in the passenger seat, you can now have some fun calculating accelerations of cars going past you and things like that. You can! And I'm a nerd of enough to kind of do some of that stuff. Anyways. So I think there's one question, maybe two questions in the homework where you get a speed in kilometers per hour and a time in seconds. Otherwise, I'd convert everything. Other ways to write the acceleration equation. Get the V final by itself. Huh? All of us right now, let's write down A equals VF minus VI over T. Evan, what does this want us to get by itself? Which one?
VF.
Okay, VF. all of you right now, put a little dot above the VF. I'll put it in red so it stands out. I want to get that by itself. This is the formula manipulation skill that we're going to be practicing, rewriting equations rather than memorizing. By the way, this equation has 4 variables. It's really 4 equations in one. I'm not going to memorize all 4 equations. How would I get the V final by itself? The first thing I would look at is that T. What's that letter T doing to the V final? Adding, subtracting, multiplying, or dividing? Where is the T sitting right now? In the bottom of a fraction, which means it's Louisa? So remember your graded equation solving rules? You learned that to move stuff to the other side, you did the opposite. If you had a plus 5 on this side, you minus 5 from both sides. If you had a 2x, you divided by 2, both sides. So instead of dividing by t on the right, how will I move the t over to the other side? What's the opposite of dividing by t? So all of us right now, we can cross out that t and put it right next to the a. So it says AT. And that gives me a slightly modified equation. That gives me V final minus V initial equals AT. It actually gives me AT equals V final minus V initial, but I just flipped the sides because it's the same equation. You okay with that, Justin, my friend? Evan, what do they want me to get by itself?
VF.
What else is next to the VF? A minus VI. See it, see it, see it, see it, see it? How would I move that minus VI over?
Add it to both.
This is the equation that you'll end up using the most, and I think this is how I gave it to you on your green formula sheet. I think it's going to be 3rd line down. Yep, there it is. Okay. If you want to know the final speed of an object, tell me how fast it started out at, the initial. Tell me what its acceleration is, Mackenzie. Multiply the acceleration by how long it's accelerating for, the time. And now I can tell you final speed without having to do this chart and find the previous 39 V finals. What if I wanted to find the initial speed? Can do that too. Oh, went too far. How would I get the VI by itself? Well, see the VI right here? See it, see it, see it, see it, see it, see it? What else is on the same side as the VI? A plus AT. What's the opposite of a plus AT? Hannah. So if I hear you correctly, the VF would just drop down like a domino. Kathunk. Yes? And you say we would minus AT, and that's VI? Yep. You're going to be doing all of this in your head within about a month. And more complicated than this, within about a month. And I will push you to do it in your head. And Ibrahim, if you can do it in your head, not only will I say do it that way, yeah, go ahead, please. I prefer you to do it that way. I will let you not show work if you can rewrite an equation in your head. So I'll let you be lazy and organized. Don, what's the next thing it wants me to get by itself? By the way, this is driving me crazy. I've got a hair on the touchscreen. I kept trying to pull the hair off, and it was moving the... I'm not used to the touchscreen being active. There we go. We did that one already. This one here. T. The T. The T. Let's go back to this one in the box because this is the handiest one to work with. See the T? See the T? See the T? Let's rewrite it right here as a matter of fact. Let's write VF equals VI plus AT. And Dom, let's put a little red dot above the T. I do that just to track it. That's what I want to get by itself. What's on the left? What side of the equation is the T on? The left side or the right side? Very good. So on the left side, see what's there? It's just going to drop down like a domino. Kathunk, it stays where it is. What else is on the right side? Well, there's an A. What's the A doing to the T? When you don't put anything in between two letters, is that adding, subtracting, multiplying, or dividing? And what's the VI doing to the T? Which do you do first? The answer is you reverse BEDMAS when you're rewriting an equation. You do your adding and subtracting first, then you do your multiplying and dividing if you can. So this VI is adding to the T. How will I move it over to the other side? So I'm not minus the T. I want the T to stay where it is. It stays there. This VI is adding to the T. How will I move this VI over to the other side? I'm going to minus the VI. Like this. And then don't write this down, but just look up. In my imagination, I imagine that the AT has dropped down. Don't write that down. I imagine that. What letter am I trying to get by itself? What's the A doing to the T? How will I move the A over? What's the opposite of multiplying? Yep. This is what you're going to write down. You're going to say the T would drop down and the A would end up like that. There is another equation. T equals VF minus VI all over A. That is a fourth way to write this equation. We have one already where A was by itself. We have one already where VF is by itself. That's the one that I gave you on your sheet. We have one where VI is by itself. We have one where T is by itself. Mandy, you can memorize all these four? Don't. I will teach you how to rewrite these in your head. Next page. Acceleration can be felt. All of you have a built-in accelerometer. Just one small problem. Works backwards. You can feel acceleration, but the direction that you feel you're accelerating is wrong. It's the opposite. I'm going to convince you of that. Supposing you're sitting in the passenger seat of a car at a red light, and the driver hits the gas. What direction do you feel like you're getting pressed? Backwards. But which way is the car clearly accelerating when the driver hits the gas? You can detect acceleration, but your body detects it backwards, the opposite direction. When the driver hits the brakes and stops quickly, which way do you feel like you're getting pressed? Yes? So which way are you accelerating when you're slowing down going forwards when you hit the brakes? Telling you. Your body can detect acceleration. In other words, if you're ever asked a direction question about acceleration, imagine you're sitting on the object. Ask, which way do I feel like I'm getting pushed? The opposite direction is the direction of the acceleration. Have you been on the elevator before at Playland? Okay? When it shoots you up, which way does your stomach feel like it's going? Down, but which way are you clearly accelerating? Up. Oh, sorry. I put those on the wrong lines. Which way do you feel like you're getting pressed? Downwards, but you're clearly accelerating upwards. Your body can detect acceleration. I usually just detect it backwards. Oh, when the elevator goes down, which way do you feel like you're being pressed? Do you feel like you're about to leave the seat and go up? Which way are you clearly accelerating then? If you feel like you're about to leave the seat and go up, and your body detects everything backwards, which way are you clearly accelerating? There's a ride at Playland called the Music Express. That's the one that goes in a circle really, really fast. And then the driver or the ride operator says, "Oh, would you like to go faster?" "Yeah!" And then it goes faster and faster and faster. Okay, got that ride. It goes in a circle. Which way do you feel like you're getting pressed on that ride? Outwards. Which way are you accelerating then? Inwards. You are. Your body can detect acceleration. It just detects it backwards. Why does it detect it backwards, Mr. Dewick? That's a much deeper question that we'll eventually get into. But right now, I'm telling you, if there's a direction question and you're asking yourself, how do I figure this out? Imagine you're riding that object. Which way do you think you feel like you were getting pushed? Pick the opposite direction. That'll work. We can finish the lesson? Hey, we are. 3 more and we're done. 3 more and we're done. Read example 4 to yourself, my angels. Aisha, what's example 4 asking me to find, my joy? So here's what I'm going to say. Fast, V. V. Which V, initial or final? Now read the question carefully and figure that part out. Yes. How do you know? This is where I say, because of English, like this is where it's an English language, read the question thing, but I'm pretty sure you're right. So I'm going to write VF equals question mark. Aisha, I underlined this phrase right here. What does from rest tell me? Which initial? V initial is what? What's that 4.5? How do you know? Two ways. They said accelerates, but even if they hadn't, I just noticed the meters per second squared. So even if they used some fancy schmancy word, change speed by, or if they didn't use the word acceleration, I could figure it out by looking at the units. This is why it's worth memorizing what units go with what concepts. What's that 3.6? In? I did a quick check. Is everything that they gave me in meters and seconds and nothing funky? So you notice I even got sloppy. I didn't even write the units anymore because I noticed they all balanced. It's when the units are weird, that's when I'm really meticulous and write them all out. I'm looking for an equation, Aisha, that has a V final, a V initial, an A, and a T, and it'd be nice if the V final was by itself. Is there one? Yes, there is. Read it to me, my joy. Where VI is 0 plus 4.5 times 3.6. Do that one in your head, Mr. Dewick? Sure, I think I can. It's going to be 18 take away 1.8. Is it 16.2? Yeah? Units, Aisha? It's a velocity. And this is where it's worth memorizing what units go with what, so also on your final step, you know what units to put there.
It's hard for me to understand what you're saying, but I think you're right.
Yep. What if it was time? What if it was acceleration? And we're just going to build on that as the year progresses. You'll have more concepts and more units to go with. I usually put a box around my final answer. You don't have to. That's my touchdown spike, the football dance. Maddie, look at example 5. See example 5? See example 5? What's it asking me to find? Seconds isn't one of our variables. Is it asking me to find VF, A, VI, or T? Okay? I know seconds is what I looked at, but what's it asking me to find? So I'm going to start out by going, oh, T equals question mark. What's that 110? What are the units next to 110, Maddie? Yuck. What is it? Not a time, because that's what they're asking me to find. Is it an acceleration? No, because if it was acceleration, what would the units be? Meters per second squared. Also, psst, you know what? What's that 8? So what is that? Let's write, hey, let's get the easier ones then. A equals 8. Okay. Folks, what's that 110? I'll give you a hint. It's a V. Ah. But I don't like the units. Because this is kilometers per hour. And Evan, what are the acceleration units? Here's where I'm going to do a conversion. Wait. Didn't we last class write down a shortcut on our green sheet? How do I go from kilometers per hour to meters per second? It had something to do with a 3.6. Is it divide by 3.6? I'm just going to go divide by 3.6. Come on, calculator. Open. There we go. It's getting there. 110 divided by 3.6, and I got 30.555. I'll write 30.5 repeating, I guess. And now that's meters per second. My units match. You okay with that, Maddie? What's V final? There's a physics word that tells us what V final is. Can you see it, folks? So all of you take your pen or pencil out. As a number, what's my final velocity, Maddie, my joy? 0. See how we got that? Okay. So you'll start to spot at rest, stopped, came to a stop. A ended at rest, those kind of things. Maddie has cleverly gone back. I saw you. Yep. We're looking for an equation that has a T, a VI, a VF, and an A, and it has the T by itself. Read it to me, kiddo. So it's going to be 30.5 repeating minus 0 all over. Oh, wait. I did this wrong. What's V final? 0 minus, what's V initial? 30.5 repeating. 30.55, 30.56 would work as well. Over, what was A? 8. Maddie, looking at this question, are we speeding up or slowing down? You're right. How do I know? Because we came to a. Okay. So I'm going to ask you the same question. I want you to say it loud and proud. Are we speeding up or slowing down? I'm going to ask you the same question. I'm going to phrase it slightly differently. Am I expecting a positive acceleration or a negative acceleration? The fact that you do get a negative here does not make me nervous. It suggests to me I did this one right. Okay, so we're also going to start to interpret our answers. By the way, everybody look up. You have decent calculators? Is this a fraction, Maddie, my joy? Say yes. Is there more than one thing on the top? Brackets. Everybody on your calculator, you're going to go bracket. You're going to go 0 minus. Maddie, did you actually on your calculator go 110 divided by 3.6?
No.
Okay. I would have done that first. And the reason is, instead of going 30.56 or 30.55556, you all have an answer button somewhere on your calculator. I would use my answer button just for accuracy. Close off the top. Divided by 8. And I get negative 3.81944. You know what? How many sig figs should I go to in this question? Well, the 8.0 is 2 sig figs. 110 is 2 sig figs. So I'll go negative 3.8. Units, Maddie. Time. Oh, I love the way you did that. You put some scorn in your voice and you give kind of a duh seconds. Yes, that's why you memorize what units go with what concepts. Okay? That I can't call it a no-brainer because you need to know the physics and memorize, but once you get there, it becomes a no-brainer. There you go. Example 6, last one. Brady, you want to drive dragster? Let's drive dragster, you and I. Brady, what's example 6 asking me to find? What is its? So let's all write down A equals question mark. Look for numbers and physics words. Brady, my friend, from rest, what does that tell me? VI is good. By the way, reading this question, are we speeding up or slowing down? What do you think, Brady? Looking at the numbers, are we speeding up or slowing down? I'm going to ask you the same question. I'm just going to phrase it slightly differently. Reading this question, am I expecting a positive acceleration or a negative acceleration? Yes. I already know that ahead of time. If I got a negative, I'd freak out. So there's some built-in error checks, and I'm going to really teach you to try and spot those along the way. Let's keep reading. I see a 37.8. What's that? That's acceleration? How do you know? What are the units for acceleration? First of all, what are they asking me to find? Why would that be, and don't take this wrong, why is acceleration a bad guess? What are they asking me to find? What are they asking me to find? So if they are asking me to find the acceleration, would they tell me the acceleration? No. Okay, so I'm going to argue don't take this wrong, that's a bad guess. Yes? 37.8 meters per second, what's that? Is it time? What's time measured in? So what do I measure in meters per second, Ibrahim? I think I saw your lips move. Was I wrong? Sorry, I thought I saw your lips behind there moving the right answer. What is this 37.8, folks? Chantel. Speed's not one of our things. What letter? VF? Yes? These are our 4 concepts for today. V final, V initial, acceleration, and time. You okay with that, Brady? What's that 2.1? And I did a quick double check. Evan, are our units nice, or do you see hours and kilometers anywhere in here? So I actually noticed that ahead of time, which is why I didn't even bother writing out the units. They're good. Brady, my friend, I'm looking for an equation that has an A, a VI, a VF, and a T in it, and it'd be nice if the A was by itself. There is one, my friend. If you're not sure, look up. It was this one in red, I think. Read it to me. And that's how we'll read it. We won't read it as acceleration equals final velocity minus blah, 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 blah. A equals VF minus VI over T. So we'll just say the letters. I totally agree with you. And we're expecting a positive answer, yes? A equals VF minus VI over T. Let's plug in numbers. VF 37.8 minus VI 0 all over 2.1. Brady, is that a fraction? Say yes. Is there more than one thing on the top? I'll have to put brackets around the top. This is where you can practice with me on your calculators. Is there more than one thing on the bottom? I don't need brackets around the bottom. Get your calculator out. It's going to look like this. Bracket 37.8 minus 0. Mr. Dewick, will the minus 0 make any difference? Technically, no on this one. But if there was a number there, this is how I would type it. Close off the top, divided by 2.1. What's the acceleration? What'd you get? Got your calculator out? Yeah, you? You have a calculator here? See, I knew how to pick on you. You all get 18? Is that big? How big is an acceleration of 18 meters per second squared? Is that big? We'll talk about how we measure acceleration, and an easy way to measure it is in terms of G's. In a few weeks, actually in a few lessons, you'll have learned this is about 2 G's, a little less than 2 G's. Fairly big. You feel like you're getting pressed into your seat pretty good. Wait a minute, Brady, what was the second word of this question? The second word of this question starts with letter D, ends in letter R. Dragster should be a big acceleration. Okay? I will try my best, Hannah, to give you numbers that are legit. I wouldn't give you a dragster question and have the acceleration be 0.1. That someone's losing some money on that dragster. Nor will I give you an acceleration question where the dragster has an acceleration of 800, because that would kill people. Okay. What's your homework? Going to do these on a separate piece of paper? Well, let's see here. Number 1. Number 2. In number 2, since it wants the answer in meters per second squared, you'll have to convert the 45 and the 72 into meters per second. Something to do with a 3.6. I can't remember what. 3 is good. 4 is good. Usain Bolt, although he's retired. 5 is good. 6 is good. So 6 is introducing you to the notion of G's. We'll do a whole lesson on it. But 1 G is about 9.8 meters per second squared. Skip 7. 8 is good. Those numbers are accurate, by the way. I took a Tesla for a test drive a couple of summers ago. Very nice. Anybody been on California Screaming at Disneyland? Okay, there you go. These are accurate. I Googled the numbers. 9 is good. 10 is good. 11 is good. Skip 12, skip 13, 14. So you got about 10 minutes. And I gave you, I think, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 questions. If you average about 1 question every 60 seconds, you'll have no homework. If you're feeling a little bit confused, it's going to get clearer in the next few lessons. Let me hit pause.